The $15 zero-energy water pump, an ancient Roman hack for modern gardens. Hello, gardeners and soil lovers. Welcome back to Earthly Delights. Before we talk about tomatoes, lettuces, or peppers, I want you to do something simple. Picture yourself standing in the middle of your garden and just listen. If you're like most modern growers, you don't hear quiet. You hear a system at work, the pump kicking on, the timer hissing, the generator buzzing, the hose scraping as you drag it across the yard for the 100th time. And if you grow indoors too, you know that same feeling. Grow lights, humidifiers, fans, everything humming like your plants need a power grid just to stay alive. That's the sound of dependency. A lot of you watching are juggling real life with real plants. You're the person who waters before school or after work. You're growing in raised beds, buckets, balconies, tiny backyards, or a few precious rows on rented land. You care about soil health, not just quick results. You want systems that are simple, affordable, and reliable. Because you've felt that panic when the weather turns brutal, when the power flickers, when a cheap plastic part cracks, and suddenly your plants are the ones paying for it. For years, we've been trained to believe moving water requires noise, and that noise requires electricity. We see a thirsty plant uphill and instantly think, machine. We treat water like something we have to push, force, and wrestle into place, with money, cords, and complicated gear. But here's the hard truth. Every upgrade can quietly become another point of failure. And that's why today's episode matters. Because I'm going to show you a way to move water that doesn't rely on a motor, doesn't need a wall socket, and doesn't wake up your whole yard with mechanical grinding. A zero-energy water pump you can build for around $15, powered by gravity, guided by an ancient Roman understanding of hydraulics, and made to run in calm, steady silence. If that sounds almost too good to be real, stay with me, because once you understand the physics, you'll never look at irrigation the same way again. And before we dive in, subscribe to Earthly Delights so you don't miss the next parts of this build, where we turn simple materials into a system that keeps your soil evenly moist and your plants thriving. Part 1. The Illusion of Force. Modern versus ancient mindsets. Now here's where most gardens start to break down. Not because the grower doesn't care, but because we've been taught the wrong relationship with water. We step outside and act like a commander. We point at a dry bed and think, move, go there, now. So we muscle it. We lift watering cans and fight gravity with our backs. We drag hoses like we're hauling anchors. And when that gets old, we upgrade the struggle. Install a powerful pump and fight gravity with a motor instead. Different tools, same mistake. Because every time you use brute force to overcome a basic law of physics, you pay for it somewhere. You pay in exhaustion, you pay in noise, you pay in heat, friction, broken seals, clogged filters, and that one maddening moment when a tiny part fails on the hottest day of the year. Physics doesn't get angry, but it is patient, and it always collects the bill. Eigen growers understood something we keep forgetting in our high-tech world. Water doesn't need to be bullied, it needs to be guided. The Persians, Greeks, and Romans didn't build their systems by fighting nature. They built them by learning how nature already moves water, then arranging the landscape so water could do what it wants to do. And what water wants, always, is balance. If you connect two containers at the bottom, water rises and settles until both sides reach the same level. Quietly. Relentlessly. No electricity, no drama. That's the power of communicating vessels. And once you feel it in your bones, you start designing gardens differently. But here's our backyard problem. Our water often sits in a barrel or tank, trapped behind a rim like it's inside a castle. It can't flow to the beds until it gets over that edge. So instead of buying more force, we use a trick that feels like magic the first time you see it. An elegant cheat of visual logic that ancient engineers mastered. We let water climb over the wall, with a siphon. Part 2, Echoes of Empires, the history of water. To appreciate the $15 system we're building, we have to zoom out and remember this. Water has always been power. Long before plastic timers and electric pumps, empires rose or fell on one skill, moving water without wasting energy. In the ancient Near East, Assyrian builders carved stone basins into river gorges and linked them with channels so gravity could do the work. Along the Nile, Egyptians relied on muscle, lifting water up from the river day after day, because crops meant survival. Then the Greeks began naming the rules behind it all. They realized that higher water carries pressure, and they used that invisible force to make fountains burst from sculpted bronze faces. Physics turned into art. But the Romans took it to a city scale. When they met deep valleys where an aqueduct bridge was too expensive, they switched from open channels to sealed pipes, often heavy fistulae, and ran them down and back up the far side, an inverted siphon. The weight of incoming water drove the flow through, building surprising pressure with no electricity at all. Romans even managed that flow with strict measurement and math, because 1 million people can't drink on guesswork. And that's our connection. The same forces that supplied ancient cities are about to live inside a humble bucket, right beside your garden beds. Part 3, the invisible engine, the physics of the vacuum. So if we're not using electricity, and we're not using a motor, what is the fuel for this zero-energy pump? It's the sky itself. Right now, as you listen, there's an invisible weight pressing on every square inch of your garden, on your soil, your water barrel, even on your shoulders. That force is atmospheric pressure, and at sea level, it pushes down at about 14.7 pounds per square inch. That's not a gentle touch. That's enough pressure to raise a column of water up around 34 feet, if you simply give it the right path. This is why a straw works. When you sip from a drink, you're not really pulling liquid upward like a tiny pump. You're removing air from the straw. You create a low-pressure space, and the atmosphere does the heavy lifting, pushing down on the surface of the drink and forcing liquid up to fill the empty space. Nature doesn't like a vacuum, so it rushes in to correct it. Our bucket system uses that same relationship, but in a way that serves your garden. When we seal a container airtight, we trap a pocket of air above the water. As water tries to flow out the bottom into your irrigation line, that trapped air expands. And because fresh air can't enter to replace it, the pressure inside drops. That drop creates a gentle hold, a counterforce that resists gravity just enough to tame the flow. Here's the image I want you to keep. Water in the tubing behaves less like a chaotic splash and more like a continuous chain. Gravity pulls on the long downhill leg, and that pull helps maintain a partial vacuum at the top, encouraging the next link of water to follow. Suddenly, you're not forcing water to obey you. You're letting pressure and balance do what they've always done, quietly and faithfully. And once you understand that, building the system becomes surprisingly simple. Part 4, Anatomy of a Miracle, the materials. Now that you understand the invisible engine driving this whole idea, we can shift from ancient theory to something you can actually build on a weekend. And this is where I want you to slow down, because the materials are simple, but the reason each one matters is what keeps the system reliable. When we're working with siphons and vacuum, a tiny shortcut doesn't just make it less efficient, it can break the physics entirely. First, the pressure vessel. We're using a standard 5-gallon, food-grade HDPE bucket, the kind you've seen 100 times. But in this project, it isn't a bucket, it's a pressure chamber. HDPE holds its shape well, it's chemically stable, and it won't complain when the pressure inside changes. That stability is the foundation. Second, the lid, and this is where most DIY builds fail. A cheap, snap-on lid is basically a leak with good intentions. If air sneaks in, your vacuum disappears, and your beautiful silent system turns into a confusing trickle that won't behave. A gamma seal lid solves that with a proper gasket and a screw top. The best part? As pressure drops inside, the seal actually tightens. The system reinforces itself. Third, the bulkhead fitting. A simple half-inch threaded bulkhead with a washer installed near the bottom. Bottom placement matters because it avoids looping tubing over the rim. Loops trap air, and trapped air is the enemy of a siphon. We're building a clean, direct exit. Fourth, the distribution tubing. Black poly tubing. Always black. Clear or translucent lines invite sunlight, and sunlight invites algae. Algae invites clogs, and clogs invite failure. Finally, the emitters. Tiny, inexpensive, adjustable drippers. These are the steering wheel of the whole system. They add just enough resistance to turn a strong siphon into a gentle, controlled drip that your soil can actually absorb. Part 5. Forging the bridge. Building the system. All right, this is the moment we stop talking about theory and start forging the bridge. And I call it a bridge for a reason. We're building a pathway that lets water cross a boundary it normally can't cross, then glide downhill to your plants in one continuous, obedient column. The goal is simple: airtight, smooth, and uninterrupted. We begin by drilling a hole close to the bottom of the bucket, not halfway up, not near the rim, low and clean. After you drill, don't rush. Take a knife or sandpaper and remove every plastic burr until the surface feels perfectly smooth. A tiny ridge can create a tiny leak, and a tiny leak is all it takes to invite air into the system. Next, install the bulkhead fitting from the inside out, keeping the silicone washer on the inside wall. This detail matters because it lets the pressure of the water press the washer outward, strengthening the seal instead of fighting it. You're not just assembling parts, you're arranging them so physics works in your favor. Then attach your half-inch main line to the bulkhead. Think of this line as the garden's artery. Lay it with a consistent downward slope toward the beds. No high loops, no surprise hills. A siphon hates air pockets, and air pockets love high points. Use staples if you need to, but keep the path steady, like a calm downhill road. Now you can branch out. Punch holes into the main line, add your connectors, and run smaller tubing right to the root zones, where water actually matters, not where it evaporates. And then comes the critical step: priming and sealing. Fill the bucket to the brim. Open the lines and let water run until every last bubble is purged and the tubing becomes a solid chain of water. Only then do you screw the gamma lid down tight. In that moment, you've locked water and air into a quiet standoff. Gravity is ready to pull, and the sealed vacuum is ready to hold. Part 6. Taming the flood. Calibration and the soil biome. You've built the structure, now we teach it to breathe. Because if you stop right after assembly, you don't have irrigation, you have a fast siphon. And a fast siphon is basically a polite flood. It can drain a full bucket in minutes, leaving your bed soggy today and dry tomorrow. So this is the step that turns raw power into a dependable rhythm. We're not trying to water harder, we're trying to water smarter. Walk the line to your emitters and adjust them slowly. Don't chase a spray. Don't chase a steady stream. What you're looking for is a pause, a single drop that forms, holds for a heartbeat, then releases. That hesitation is the sweet spot. It means the system is meeting your soil at the pace your soil can actually drink. And that pace matters more than most people realize. Soil is a living biome, not a sponge. When you blast water too fast, it can't infiltrate evenly. It runs across the surface, evaporates into the sun, or worse, carries away fine particles and nutrients you worked years to build. But when water arrives drop by drop, it doesn't run. It wicks. Capillary action pulls that moisture outward beneath the surface, forming a deep, widening cone right where roots and microbes are waiting. That slow, steady hydration keeps fungal networks intact, keeps bacteria active, and encourages roots to grow downward instead of staying shallow and stressed. In other words, you're not just watering a plant, you're feeding an underground community that will protect that plant for seasons. Here's the beautiful part. As the bucket releases water, the trapped air expands and the internal pressure drops a bit more, gently slowing the flow. Over time, the system finds its own balance. Gravity pulling, vacuum holding, atmosphere pressing, until you get a remarkably consistent drip. The kind of consistency people buy expensive regulators to achieve. And you're getting it with quiet physics while you sleep. Part 7. The enemies of the siphon. Troubleshooting. Now, anytime you choose to work with natural laws instead of brute force, you also accept the rules of the game. This $15 pump is surprisingly tough, but it has two main enemies, and they're both quiet: air and sediment. Let's start with the one that stops everything instantly: air intrusion. A siphon depends on a continuous column of water. The moment a bubble gets trapped at a high point in your tubing, you can create what growers call an airlock. And airlocks are sneaky because air behaves differently than water. It compresses, it expands, it cushions pressure changes. That trapped bubble can act like a plug, literally holding back the weight of the water behind it until flow collapses. So the first defense is design. Keep your main line sloping downward with no unnecessary loops. If your tubing has to go up and over a mound or rock, treat that high point like a danger zone. During setup, make sure you flush the line with a strong, steady flow before sealing the bucket. Enough movement to sweep bubbles out instead of letting them cling and gather. And if your terrain forces a high point no matter what, a tiny air release valve at the top can vent the problem before it grows teeth. The second enemy is vacuum failure. This system doesn't forgive leaks because the vacuum is what keeps gravity disciplined. Over a hot season, plastic expands and contracts. UV works on seals, and a gasket that dries out can become the doorway where air sneaks in. When that happens, gravity doesn't argue, it just wins, and your bucket can drain faster than you expect. So, protect the bucket, keep it shaded, paint it a light color, or wrap it so the water stays cool and the plastic doesn't bake. Once a year, give the lid's O-ring a thin touch of food-grade silicone grease. And if something does fail, don't guess, test. Brush soapy water along fittings and seals. The vacuum will pull it in at the leak, and you'll often hear a faint hiss that points right to the weak spot. Part 8. The ram pump, Heron's fountain, and the permaculture future. By now you can feel it. This bucket isn't just a DIY project, it's a mindset shift. And once you start looking through that lens, you realize the vacuum bucket pump is only one ancient trick in a much bigger toolbox. The real skill, as growers and homesteaders, is knowing which tool fits which landscape. Take the hydraulic ram pump. It's a brilliant machine for places blessed with a running stream and a drop in elevation. It uses the momentum of moving water to create a water hammer effect, then turns that pulse into lift, sometimes sending water far uphill with no electricity at all. For a larger farm, it can be a game changer. But there's a trade-off. It spends a lot of water to create that force. It's not designed to be stingy, it's designed to be powerful. Then there's Heron's fountain, an elegant, almost theatrical invention from the ancient world. It uses air displacement between hidden chambers to throw a jet of water upward, like a little physics miracle on your workbench. But it's a batch system. It performs, then it stops, and it asks for your hands to reset it. That's why for the small-scale, off-grid garden, the vacuum bucket pump shines. It doesn't need a stream. It doesn't depend on complex valves. It doesn't waste water to make water move. In terms of efficiency, it's brutally honest. Nearly every drop you release goes to roots, not to powering the machine. You fill the vessel, seal it, and let the atmosphere press the water gently into your soil like a steady heartbeat. And this is where permaculture starts to feel less like a philosophy and more like a practical survival skill. In rooftop gardens, suburban beds, and remote homesteads, systems like this are spreading because they're appropriate technology, simple, repairable, and resilient. When weather gets extreme and grids get shaky, you don't want irrigation that fails dramatically. You want irrigation that fails safely. If the bucket runs dry, the flow stops. No motor burns out. Nothing melts. You refill it, reseal it, and your garden begins again. The profound silence of a living garden. As the light drops and your garden settles into evening, you start to notice something most of us have forgotten how to hear: the sound of a living system. Not the buzz of a timer, not the grind of a pump, just wind through leaves, a distant bird, the soft hush of soil doing its quiet work. And that's the real difference, isn't it? A garden kept alive by technology will always feel a little tense because it survives on a chain of devices that can break. But a garden kept alive by design feels calm because the forces holding it together are older than any machine we could buy. Standing next to this simple $15 setup, you realize you didn't just build a bucket with tubing, you bought silence. You bought freedom from dragging hoses until your shoulders ache. You bought the ability to leave for a day or a week without that low-grade anxiety that something electronic might fail while you're asleep. No extension cords in wet grass, no replacement parts aisle, no monthly bill creeping up because your plants needed a motor to drink. This system doesn't hum, it doesn't vibrate, it doesn't demand attention. It just sits there, humble and steady, letting gravity pull, letting the atmosphere press, letting water arrive at the roots the way soil was designed to receive it, drop by drop, patient and precise. Simplicity is durability in its purest form. We don't need more power to grow food. We need a little height, a good seal, and the wisdom to stop wrestling the universe. Thank you for spending this time with me on Earthly Delights. If this ancient approach resonated with you, subscribe, share it with a fellow grower, and tell me in the comments what other forgotten, practical technologies should we bring back for the modern garden. Until next time, keep your hands in the dirt and let nature do the heavy lifting.